Like being a human hockey puck.
On his homemade hoverboard,
Here we go, give me a push.
college physics professor David Wright teaches us Newton's first law. Motion stays in motion.
You have to be enthusiastic in the class because physics has got a reputation as being dull and boring.
No chance of dozing off in Wright's classroom. He's been sharing the gravity of a science he loves at Virginia's Tidewater Community College since 1974. At almost 70, a magnetic machine of energy. Slingshotting himself into demonstrations with fire, pogo sticks, even a bed of nails.
I feel kind of guilty sometimes. They're paying me to have fun.
One student posted this stunt montage just yesterday on Twitter, already watched more than 13 million times.
You have to be going into that classroom every day thinking, what is this guy going to do today?
Literally, yes. Literally.
His class is a roller coaster ride. And while Wright gets thrills from the physics of skydiving and bungee jumping, nothing compares to teaching.
Look what happened.
Using a closet collection of gadgets to engage and inspire.
Nice job. You're a natural. Yeah. I love coming to work in the morning. I've loved every minute of it.
A passion and a purpose even science can't explain. Katie Beck, NBC News, Virginia Beach, Virginia.
Hello, everyone. My name is David Wright, and I love physics. I also love to teach. I want to commend each of you for being here at the Pathfinders Summer Institute. You're terrific, hardworking teachers striving to become better. Now, in my 45 years of teaching at Tidewater Community College, I've been involved in a lot of professional conferences, attended workshops, read journal articles, talked to colleagues, experimented in the classroom, and trying a way to make my instruction and my teaching better. I love professional development. Let's start by talking about the principle of inertia. Inertia says that objects at rest stay at rest, and objects in motion stay in motion at a straight line at a constant speed unless acted upon by an outside force. Let's see how this works. We've got some dishes. They're at rest. They want to stay at rest. If I pull hard and fast, they'll do that. 1, 2, 3. Awesome. Now, over here in the back of my room here, you'll see an egg, a raw egg on top of a PVC pipe, a pizza pan, and then a container of water underneath. I'm going to use this broom as a striker. It's going to apply force to the pizza pan, knocking the pizza pan that way, but nothing attacks the egg. It should fall straight down because of the principle of inertia. Here we go. 1, 2, 3. Try it again. 1, 2, 3. Perfect. Okay. Now the next principle of inertia has to do with this wheel. It's a bicycle wheel. I'm going to start it spinning. I apply a force to get it going. What keeps it going? I ask my students that question all the time. They say inertia, but no, nothing keeps it going. Inertia is the name of the principle. Inertia is not a force. It'll spin forever until the friction eventually slows it down. But why does it keep going? The answer is, we have no idea. Just the nature of things. That's the answer to a lot of questions in physics. Why do protons attract electrons? And the answer is, because they do. It's their nature. Now, people say that education has a lot of inertia. That means it's hard to get things moving, either to get them started or to change their direction. You may have colleagues that have been teaching the same way for many, many years, no desire to make any changes in what they're doing. You're the Pathfinders Institute. You're going to break that status quo. You have great instruction. You're going to collaborate with peers. You're going to have an educational, interactive, and fun experience. And you're going to want to share the experiences with your classes when you get home. You can't wait to do that. Now, you're starting off on a new track, but how do you do it with little funding? Well, one idea is that manual I gave to you beforehand, the video and demo manual. A lot of exercises and things to do that are easy and cheap. I'll give you an example. Even if you're not a physics person, there'd be a lot of exercise you can use in your classes too. This is a Koosh Ball, my favorite physics demonstration device. It's very versatile. It's like the Swiss Army knife of physics demonstration devices. It's so useful. It's easy to see, colorful, easy to catch, and it doesn't bounce. Now, If I toss it back and forth like this, it follows a nice parabolic path, which is what free fall is all about. If I hold it by a couple of strands and I spin it very fast, it flattens out. That's pretty cool. And then it also oscillates back and forth. It's a torsional pendulum. Ooh. Now, if I take the Koosh Ball and I go this way and toss the Koosh Ball that way, watch what happens. The Koosh Ball just dropped down. That's an example of relative velocity. That's so cool. Now, we can also do this. Put the Koosh Ball on a board, hanging from a board like this, spin in a circle, and the Koosh Ball stays on the board. Yeah, how about that? Fell off at the very end. Try it, you'll love it. Now, demonstrations are a great way to get a discussion going in the class and relate to the real world. I love to ask questions, but so often in class, I'll get 2 or 3 students that raise their hand and the rest of them just are happy just to sit there and do nothing. I want to have an engaging and interactive classroom. So I use a classroom response system, sometimes called clickers. There's also free apps you have on your phone, like Pull Everywhere. One of my favorites is the low-tech version. See, B, A, C, and D. That's pretty cool. Because if you use these response systems, you can get the whole class involved in making predictions and answering questions. You can see as an instructor what they're learning, whether they get it or not. It makes them think about things as opposed to just writing it down in their notes, being a scribe. And they don't have to be embarrassed because only you see the answers, not their peers. They don't have to be embarrassed about that. Now, I like to make predictions in class. And then we'll do the experiment, and then we'll talk afterwards about what it all means. So we're going to try it right now with buoyancy. What we've got here is a tank of water and 11 different items we're going to toss into the tank of water, and we'll see whether they sink or whether they float. Now, if we had your clickers or your personal response system, we could have you vote along the way, but you have to keep track yourself. All right, let's start off with a rubber ducky. Start off easy. Rubber ducky. Float or sink? Well, that's an obvious one. You knew it was going to float. It doesn't float very well. This next one's easy. This is a rock, a piece of granite. And it sinks like a rock? Okay, you got that one. The next one's a little tricky. The next one is a golf ball. Okay, vote, golf ball. It sinks, not very quickly, a little more dense than water. A rubber stopper. All right, standard old rubber stopper. Let's see what happens. Boom, down to the bottom it goes. How about a tangerine? Well, it floats pretty well. Now, softball. Softball. Look at that. Only floats about halfway down. It has about half the density of water. Let's try an apple. Have you bobbed for apples before? Yeah, that apple does a nice job, doesn't it? Floating. Hard to get with your teeth. Let's try a potato. Just a standard old potato. Sink or float? It sinks. Interesting. How about some grapes? Green grapes and black grapes here. Yeah, they sink to the bottom. Diet root beer. No bubbles down there. Nope, it's floating quite nicely. Floating quite nicely. How about a regular sugar soda? Oh yeah, it sinks to the bottom. This brings up a great discussion about buoyancy. It's all about density. For example, an 11-pound bowling ball floats, interestingly enough. Surprise, surprise. A 13-pound bowling ball sinks. Now the students might say, well, it's heavy, that's why it sinks. But 100,000-ton aircraft carrier floats. It's all about density. Bowling balls have exactly the same size. Therefore, the heavier one is also denser, and that's why it sinks. Now, I love to have fun teaching. So I did a long time ago, if I wasn't having fun teaching, my students wouldn't have any fun learning. I also like to make it real world. It makes it relate. to what they're doing. I like to use a lot of energy. I figure if I have a lot of energy, a lot of passion on what I'm doing, I can transfer some of that, at least anyway, to the students. Let's see an example of that. Here I've got a basketball. Camera down a little bit. I've got a basketball here. I'm going to bounce it on this chair. Maybe straight. There we go. And I'm going to bounce the tennis ball. All right. I'm going to bounce them both together. Whoa! The tennis ball went up and hit the ceiling. Where in the world did you get the energy to do that? What's going on? Is it magic? No, it's physics, because the basketball gave some of its energy to the tennis ball. Like you as an instructor can give some of your energy to your students. It's exciting stuff. Okay, next we've got the spinning stool. Sitting on the stool, spins around. Okay, that's like the figure skater. Things are on them, they spin faster. It's good to get the students involved in demonstrations, have them experience the science and not just talk about it. They love it. Here we go. Bricks out, spin around, bring them in. Ooh, faster, slow, ooh, faster. And then I'm getting dizzy now. I love the students to do these kinds of things. Oh my goodness. All right. They like to be able to explain things that happen in the real world. This is the board. You notice how the grain is on the wood. This is the 1x12, cut into 3-inch pieces. We're going to use this to, oops, too much. Experimentation here. We're going to break this right here on the table. Normally have the students hold it like this. I don't have that right now. So let's see. Right here. Think I can do it? Students aren't sure. Use the heel of my hand here. 1, 2, 3. Hi-ya! Oh, yeah. Very cool. Now, the principle here is action and reaction. For every action, there's an equal and opposite reaction. You can't hit without being hit. As a matter of fact, it's an interaction, my hand and the board. Forces are all interactions between two things, the earth and the moon, the hand and the board, a foot and a football. It's always an interaction. But you know what? Teaching is also an interaction between a teacher and a student, between a student and a student. You can't just convey information or give instruction in that fashion. You've got to interact to be able to really teach. I love teaching. I want to make it fun. I want to put a lot of energy into it. I want to make it real, and I want to engage the students in discussion and thinking and interaction. That's what it's all about. Now, at the Pathfinders Institute, you're going to have a lot of skills you're going to go over here. You're going to learn how to reach your students. You're going to have an amazing time this week.